All right, good morning, everyone. So I decided to shoot this video because I had a couple of people that had some questions on the transformation of radical functions. So let's go ahead and jump straight into it. All right. So this first one here, first we're just looking at our two parent functions. So these are just like our original radical functions. So this first one, obviously you can see we're taking the square root of x. So let's go ahead and fill out this chart that we have here, right? So let's say if x represents our domain values. Well, if I put in the square root of 0, well, the square root of 0 will just give us 0. The square root of 1, right? Well, 1 times 1 is 1, so this will just be 1. The square root of 4, so we know that 2 times 2 gives us 4, or the square root of 4 is 2, right? So we're going to put 2 here. The square root of 9 would be 3. Now, this is actually interesting when we're talking about the negative square root, right? So going back to what we learned in, our lower grades, can we take the square root of a negative number and it'll be a actual real number? Well, if you said no, you've guessed it right. So in this case, this is an A, right? Like we can't even graph this. So let's say if we wanted to graph this over here on the portion or on the plot below. So the function will look like this. When we're at 0, we're at 0. When we're at 1, we're at 1. When we're at 4, we're going to be at 2. And when we're at 9, we're going to be at 3, and so on. So we're going to kind of curve up this way. All right, could have made a better curve, but forgive me, it's my first time using the software. Okay, so this will represent your parent function here. That's when we're taking the square root in that case. All right, so now let's talk about this section, the second one with the cube root. Well, when you take the cube root of something, you need something to be multiplied by itself 3 times. So let's say if we took the cube root of -1. Well, we can break this down into -1 times -1 times -1, right? Because if we multiply this 3 times in a row, this gives us 1. If we multiply by another -1, this gives us -1. So the cube root of -1 will just be -1. All right. So the cube root of 0 is 0. Cube root of 1 is 1. So let's say if we were talking about the cube root of 8. Well, what number multiplied by itself 3 times gives us 8? Well, that would actually give us 2. So this is going to be 2 here, right? And conversely, the cube root of -8 is -2. So let's say if we plot this at 0, 0, we're here. At 1, 1, we're here. At 8, we're at 2. At -1, we're at -1. And at -8, we're at -2. So let's say if we kind of graph this curve here for us. Should look something similar to this portion here. All right, something like this. So you should notice a distinct difference between the two. So let's say if we were talking about the first one, going back to our original one, we know that let's say we were talking about our domain, right? Let's say we were talking about our domain values. So in this case, our domain values, well, our domain values are kind of restricted because we can't have a negative number, right? It can't go negative. So our domain values are going to be restricted in such a way that x needs to be greater than or equal to 0, right? And conversely, let's say we're talking about our range values. Does our range value have some type of restriction? Well, yeah, because it looks like we can't have a negative number because we can't, when you take the square root or when you're squaring something, it always comes out positive. So you could say your range is going to be y is greater than or equal to 0. Now let's look at this other example here with the cube root, right? Well, our domain, is our domain restricted the same way as the square root of x? Well, actually, it's not in this case, right? So because we can have both positive and negative numbers, so we could say our domain is from -infinity to positive infinity. All right. And how about our range? Is our range restricted? Well, it looks like our values are increasing, right? Our y values are increasing and decreasing. So our range here would be the same as well. Negative infinity to positive infinity. So the biggest thing to kind of look at is the biggest distinction between a even root, you're going to have some type of restriction, and the odd root is going to kind of be unlimited. So let's say if we go down to our index and roots. So we know that with an index, right, our index is just kind of like the number up top, right? So let's say if I had the square root and this box here, and this is x, right? So this index here, this box up top, that would actually represent the index. Okay, that would represent the index, and then the box underneath, right, this x here, that's what we call the radicand. All right, so let's say if you have the square root, right, your index is 2. We don't usually put 2, but you want to imagine like there's a 2 up there. If you're taking the cube root of something, your index is 3, right? The fourth root, your index will be 4, and the nth root. Okay, so these aren't necessarily exponents. This is like you taking the root of something. All right, so also moving on to our transformation. So just kind of brushing up on our transformation rules. As you can see, a, when you have a times f of x or a times the radical sign, you're just doing a vertical stretch or compression, right? It's going to be either stretching upwards, right? It's either going to be stretching upwards, so kind of going upwards, right? Or it's going to kind of be getting flatter, right? So a lot of times I try to tell people, think about a slinky. When you pull a slinky upwards, it stretches. When you crush a slinky, right, it flattens. Okay, so that's a vertical stretch or compression. If your a value is less than 0, it's going to reflect over the x-axis. Now let's talk about our vertical translations, right? So you're just adding k. This is just going to help you shift up or down the graph. So one thing, what I will say is all vertical transformations. So let's kind of just summarize it a little bit. But what I will say is, so vertical transformations, they're outside the radicand. Okay, anything that's happening vertically is outside the radicand. Now, conversely, let's say we're talking about our horizontal stretch or compression factor, this portion here, right? So it's 1 over b. One thing you want to kind of think about is whatever your factor is, it's the reciprocal of that factor. So let's say if we had a factor of 4, right? If we had a factor of 4, well, what we will be entering into that radicand will be like 1 over 4 times x. But if we had a factor of 1/4, right, then you'll be entering 4x. So you just reciprocate them, right? You just reciprocate them. Horizontal translations, right? We know this is going to help us move left or right. Okay, so this helps us move left or right. So in this particular case, what you want to kind of think about is what value in here makes this 0? What value of h will make this 0? And that's the direction you're moving, right? So if h, let's say if you had something like x minus 6, well, what value of x will make that 0? Well, it'll be positive 6, so this means you're moving left. I'm sorry. So it'll be positive 6. So this means actually you'll be moving right 6 units. Okay. So you're going to move to the right 6 units. And sometimes that can be a little tricky because, you know, naturally we think, okay, when you're subtracting something, you're going towards the negative side of the number line or towards the left, but you want to think about the value of x that will make it 0. So let's say conversely, right, we had x plus 6. Well, what direction are we moving? Well, you're going, in this case, you're going to be moving to the left 6 units, because you want to think about the value of x that will make this 0. So if we substitute a -6, that will make that 0. Okay, so once we kind of have a good understanding of our transformation rules, we kind of have that understood. Let's go ahead and look at 2 examples, and we're just going to kind of close off this video. All right. So the first example here, I want us to just think about it. Describe the transformation that occurs in the first one over here. So we're looking at this example. All right, so let's describe the transformation that occurs in this particular example. So we know the parent function, right? Our parent function is just f of x equals the square root of x, right? So what has changed? Well, it looks like we have a number on the outside. So we have 2 numbers on the outside. So remember, we said that the numbers on the outside represent vertical changes. So this portion here, let me highlight it in orange. Right here, this this 3, right? That's going to represent a vertical stretch by a factor of 3. Okay, looks good, looks good. The other vertical transformation we have is this -2 here. So we can say this is a vertical shift down 2 units. Okay, vertical shift down 2 units. All right, great. So now we have one horizontal transformation. So that's going to be this x minus 1 portion here, right? So remember, it's always x minus h, and you want to think about the value of x, right? That's going to make this 0. So what's the value of x that will make this 0? It'll be 1. So we're going to say we're moving horizontally. All right, this is a horizontal shift 1 unit right. Okay, all right, so that's the first one. So hopefully we got an understanding of that one. So let's go ahead and look at this cube root one. Okay, let's look at this cube root one. So the parent function for this cube root one will just be f of x equals the cube root of x. So with that being said, first we want to identify everything that's on the outside. So it looks like we don't have a vertical stretch or compression factor on the outside here, but we do have, however, have a shift, right? So remember, everything on the outside represents a vertical kind of transformation. So here, this +3, right? What we can say is, well, we know that's going to be a vertical shift. And since this is positive, we're going to go up 3 units. Okay, we're going to go up 3 units. All right, so now we got to look at what's on the inside. So it looks like we have 2 horizontal transformations, right? So the first transformation I want to kind of get out the way is this coefficient of x is 2x. So remember what I was saying earlier, right? We know that our horizontal transformation is 1 over bx, right? So how would you, let's say if we had 1 over b and we set it equal to 2. Well, what would be the value of b? Well, let's say if we just solve this proportion real quick, right? Or even if you just flipped it, you know that b would actually be 1 over 2. So in this particular case, if you have a 2 here, but you want to figure out your factor, right? You know your factor is going to be 1/2. Okay, your factor is going to be 1/2. So in this case, we can say this is a horizontal compression by a factor of 1/2. All right, cool. Last but not least, we have this transformation right here, okay? So we know it's inside the radicand, so we know it's horizontal, okay? That's how you should be thinking about this, to kind of, just think of it simply. Okay, inside the house, horizontal. Outside the house, vertical. So in this case, we're adding 1. So we got to think about what's the value of x that what we have here. Like, let's say if this was just x plus 1. Right, what's the value of x that will make this 0? So x would have to equal -1. Well, that's the direction we're moving. So we're going to say this is a horizontal shift one unit left. All right, so that's going to conclude us for this lesson today. Please let me know if that was helpful or anything. Please, any comments, suggestions will be greatly appreciated. All right, y'all, have a blessed one.